Today we're going to talk about word problems, some definitions. These are a review of the definitions we've already talked about. Algebraic expression, a mathematical phrase that can include numbers, variables, and operation symbols. A quick hint, there are no equal signs in algebraic expressions. Equations, a mathematical sentence that uses an equal sign. So here is where we're going to see our equal signs in equations. Inequalities, a statement that compares two expressions. Here's where we see the less than, greater than, less than or equal to, and greater than or equal to signs. Very important concept, number 1. Define a variable means to choose a letter to represent the missing or unknown value. Then, write a key explaining what your variable represents in the problem. So many times you're going to be given a word problem and it's going to say define a variable and write an equation. Well, that defining a variable means you pick a variable and you tell me as the reader what it means for that situation. Okay, so if I read your problem, I know what B stands for or what A stands for. Same could go with your parents, with the other teachers, or your friends. They can understand what your variable represents for you in the problem you're currently working on. So here's some examples. I could say S stands for the number of Skittles, B stands for the number of books, H stands for the number of hours, C is Christina's age. These are different keys to what a variable represents. We're going to start with expressions. Remember, expressions have no equal sign. Question 1, Eve reads 25 pages per hour. So what we need to do is we need to identify the key words in this problem. Per, that's an important key word. Per represents multiplication. So I know that this problem contains multiplication. I need to define my variable because I have to have a variable here. I don't know how many hours Eve is reading. So I need to make sure I identify a variable because that's what I'm going to be using in my expression. So in this case, H represents the number of hours. So she's reading 25 pages per hour, so my expression that I write is going to be 25H. That means 25 times H. I don't need to write any other symbols except for 25H because in math we just understand that means multiplication. Number 2, Sam is 25 years younger than Sue. What is Sam's age? Now, I could write an equation for this, but I'm not going to because the directions are telling me that all of these are expressions. So I need to keep that in mind. I think sometimes we get ahead of ourselves and we try to figure out the answer, but this isn't about figuring out the answer. It's about writing an expression. So we need to identify the important words, 2 years younger than. So Sam is 2 years younger than. Younger than is going to represent subtraction in this case. So I need to identify a variable. Let's just do Y, and that's going to represent Sue's age. The questions ask me, well, what's Sam's age? Well, when I evaluate this, I will figure out Sam's age, but I have to use Sue's age in my expression to be able to figure out Sam's age. So my variable represents Sue's age. Here's my expression. We're taking Sue's age and we're taking away 2 from that. So Y take away 2. Number 3, Rebecca runs a mile in 12 minutes. How many miles can Rebecca run in M minutes? Well, here they give me a variable. So I'm just going to write my key, M equals the number of minutes. That was easy. Now let's think about this. She runs a mile in 12 minutes. So if we have an unknown number of minutes, how many miles does that equate to? So I've got to take my number of minutes and divide it by 12. That will give me how many miles she's run. So it could be 24 minutes, and it could be 48 minutes, it could be 60 minutes. Whatever number of minutes she ran, we're going to divide that by 12 and get our miles from that. Now we're going to move on to equations. Remember, equations have equal signs. Number 1, Jamie and Sarah have a total of $65. If Jamie has $19, write an equation to determine how much Sarah has. So our key word here is total. Total meaning add together. There's another word here that it's of. Typically of means multiply, but here it's just explaining. It's an explaining word to show you that they have a total of $65. So in this case, of is not useful to us. Only total is useful to us. So I'm going to define my variable. X is going to represent the amount of money Sarah has. I could write this problem so that X is by itself and I can find my answer really easily, but mathematically that's not appropriate for this problem because I'm going to write this problem in order of how it occurs in the word problem. I'm going to write my answer in the order that it occurs. So Jamie has $19. Jamie and Sarah have a total of $65. So if I take Jamie's money, add it to Sarah's money, which is X, then that will equal $65. This is going to be my equation. Number 2, the sale price of a camera is $136. This is $25 less than the original price. Write an equation to represent this situation. So we are going to identify the important words. Is means equals. Is means equals. So that's how I know I'm writing an equation. $25 less than. Less than means subtract, but it's one of those words where I'm subtracting but in reverse. Remember from before? So I need a variable. My variable in this case is going to be P. I was going to put O, but sometimes O, the letter O, looks like a 0. So I chose not to use O, but use P instead. So we're trying to find out what the original price is. We don't know the original price. So whatever we don't know becomes our variable, the original price, P. So in this case, I'm going to write my problem in order of the way it's written. So the price of a camera is $136. So I put $136 down here. This is, I'm using that keyword again, that means equals. So $136 equals $25 less than the original price. So remember, this word less than, this phrase less than, means to reverse the subtraction problem. So $25 less than the original price. This is my equation. Some more equations. Grace earns $5 per hour when she babysits. How many hours does she need to work to earn $85? So we're looking for how many hours. H. In this case, H is going to represent my number of hours. Remember, you can choose any letter, but in this case, H seemed the most appropriate. So she's working $5 per hour. Per means times, so 5 times H. And we want that to equal to $85 because we want to know when she gets to $85 how many hours she's worked. So 5 times H equals 85. That is our equation. Number 4, when a package of candy is shared among 12 friends, each gets 36 pieces. How many pieces of candy were in the package? So that's the information we're missing. We need to know how many pieces of candy were in the package. So P is going to stand for pieces of candy in this case. Shared. Shared means divide by. So we're dividing here. And we're dividing by 12 friends. So P divided by 12 equals 36. So when I have my big package of candy and I divide it by 12 people, each person gets 36 pieces. This is my equation. This one down here, it's not liking the slide right now. Okay, inequalities. Remember, inequalities have these 4 signs. So my question is, in many states, you must be at least 16 years old to obtain a driver's license. So we are going to take that phrase and just rewrite it using only inequalities. We also have to define a variable here. I'm going to use the letter A, and that's going to represent the age to drive. So here's our keyword, at least. At least means I could be 16, I could be 17, 18, I could be 100 years old. So I have to be 16 years or older. That's going to be my greater than or equal to sign. So here's my inequality statement. A is greater than or equal to 16. And then secondly, a bus can seat at most 48 students. So can it seat 48? Yes. Can it seat 47, 46, 40, 12? Anything less than 48, it can seat. Can it seat 49, 50, 51? No, it cannot. So it's going to be able to seat 48 or less students. So my variable is B, the number of students on a bus. So B is going to have to be less than or equal to 48. That's my inequality.